Frictional electricity. Frictional electricity is nothing but electrostatic charges developed on insulating bodies when they are rubbed against each other. Now, what are insulating bodies? Insulating bodies are basically paper, then plastic, glass, rubber, cloth. All these are insulating bodies because they do not conduct current. Now, when there are two insulating bodies and which are rubbed against each other, what will happen? Currently, we have in this example glass rod and silk cloth. Okay, these two are rubbed against each other. What will happen? There will be electron transfer from glass rod to silk cloth. So the glass rod will have a positive charge and a silk cloth will get a negative charge. Okay, so charge on one electron or proton is given by charge on one electron or proton is given by E is equal to plus or minus 1.6 into 10 raised to minus 19 coulomb. Okay, it will be plus in case of protons and minus in case of electrons. So value of one electric charge is 1.6 into 10 raised to minus 19 coulomb. Coulomb's law in electrostatics. Now Coulomb's law states that the electrostatic force between the 2 point charges is directly proportional to the product of the magnitude and inversely proportional to the square of distance between the centers. Now let us consider 2 point charges Q1 and Q2. Now these 2 point charges are separated by distance of r. Now according to Coulomb's law, F, that is electrostatic force between the two charges, will be directly proportional to the product of the magnitude Q1 Q2 and inversely proportional to the square of distance between the centers. So F is equal to K Q1 Q2 upon R square. Now one thing to note down here is that the force between the 2 point charges will always act along the line joining the centers. It won't act in any other direction. Now coming back here, what is K? K is constant of proportionality. Okay, so the value of K is 1 upon 4 pi epsilon. Epsilon is absolute permittivity. Okay, so we can write this further as 1 upon 4 pi epsilon naught epsilon r. Now what are these two new terms? So epsilon naught is called permittivity of free space and epsilon r is called as relative permittivity. We will learn about all these terms, that is absolute permittivity, permittivity of free space and relative permittivity. In this section we will be learning about permittivity. Now what is the physical significance of permittivity of medium? Permittivity of medium gives an extent to which a medium allows electric lines of force to pass through it. That is, permittivity of medium determines the degree of interaction between the two charges placed in that medium. Let us say we have two charges Q1 and Q2. Okay, they are placed in certain medium. Now different types of medium are air, it can be water, it can be mica or other medium. Now every medium will have certain particle. Now this will be different for air, different for water, and different for rest of the material. Now this medium which exists over here, to what extent it allows the interaction between these two charges. Interaction means basically whether they are supposed to attract or whether they are supposed to repel. This interaction, to what extent it allows. Now a medium with lesser permittivity, medium with lesser permittivity will allow more interaction between charges. And as there is increase in permittivity, interaction between charges decreases. Okay, greater the permittivity, lesser the interaction between the charges. Now the permittivity of free space epsilon naught is 8.85 into 10 raised to minus 12. Similarly, E is called as absolute permittivity. Okay, and we'll learn about one more term called as epsilon r, which is relative permittivity. Relative permittivity or dielectric constant of a medium. Now I'll write down this formula. Coulombs law is given by 1 upon 4 pi epsilon q1 q2 upon r square. Okay, now this is absolute permittivity of a medium. Which will vary for different medium. Now we know that value of epsilon naught, that is permittivity of free space, is 8.85 into 10 raised to minus 12. Similarly, permittivity of water will have such big number, permittivity of other insulating material will have such big number. So every time it becomes very difficult to put this number in this formula, okay, and do the math. So what has been found out is epsilon r, which is relative permittivity, which means we have to compare the permittivity of a medium with that of air or vacuum. So relative permittivity is basically given by absolute permittivity of medium upon permittivity of free space. So basically we are comparing the permittivity of any medium with that of free space. This is epsilon upon epsilon naught. So we can know with this that how many times the permittivity of any medium is more compared to that of free space. Suppose we know that the permittivity of free space is 1 and that of water is 80, which means that the relative permittivity of water compared to that of air is 80. Okay, that means water will have 80 times more resistance than that of free air for the interaction of charges. So this is of water, this is of free space. or what we can call it as vacuum. Okay, so water will have 80 times more resistance for the interaction of charges. Let us consider 2-point charges Q1 and Q2 placed r distance apart in air. So here two charges placed at a distance r. So the force of interaction between them, if they are placed in air, then F is equal to F air is equal to K Q1 Q2 upon r square, which is nothing but 1 upon 4 pi epsilon naught, as permittivity of air or vacuum is given by epsilon naught. Okay, now the same charges are placed in other medium. Okay, we do not know which medium, any other medium. So force between the charges is given by K Q1 Q2 upon r square. So 1 upon 4 pi epsilon. This is absolute permittivity of the medium, Q1 Q2 upon r square. So we get further 1 upon 4 pi epsilon naught, sorry, not epsilon naught. We all know that E epsilon r is equal to epsilon of the medium, absolute permittivity of the medium, upon absolute permittivity of free space. Relative permittivity is equal to absolute permittivity of the medium upon permittivity of free space. Okay, so what will happen? Epsilon here will become epsilon naught, that is permittivity of free space, into relative permittivity, Q1 Q2. Okay, this becomes this because of this formula. Now if I take this equation as 1 and take this equation as 2 and divide equation 1 by 2, then I get F of air upon F of medium is equal to, this all terms will cancel out, and finally what I'll get is relative permittivity, which is also given by K. Now from this we can get that, suppose if there are two charges interacting in air, okay, and there are two charges interacting in the same two charges interact in a medium. So from this we can get that in which medium the force of interaction is more, and in which medium the force of interaction is less. Okay, so I'll calculate if I want the force in between the two charges in water, it will be F of air upon K, which will be F of air upon 80. So value of K is 80 for water. So this means that if the two charges interact in water, the force of interaction will be 80 times less than that of air. So it is very difficult for two charges to interact in water, which is basically 80 times more difficult to interact, because there are more particles in water which are densely packed, so the interaction becomes very less compared to that of air.